Hello everyone, this is Shaista Khanam from Vidyavardhini's College of Engineering and Technology. In our last lecture, we have started with the CMOS fabrication process. So just revising what we have done in the last lecture. Uh, so there are three methods which can mean there are some methods which can be used for fabrication of CMOS. So that is P-well process, N-well process and twin-top process which we are going to study. Out of that, we have seen P-well and N-well process in a last video. In order to form a CMOS circuit, so what we are doing with the help of, as we know that in a CMOS circuit, some of the connections are permanent, like the gate of both the transistors are shorted, right? So that means that can be connected internally only. So this can be done while doing a fabrication only. So for that I should know the circuit and I have to use a proper mask to do the connection. Now here first method we have seen that P-well process in which we have formed the we have created the P-well in a N substrate and we made created a N channel MOSFET in a P substrate and PMOS in a N substrate. We have seen the benefits of this P-well process is nothing but the performance of both the transistors are same. As I discussed in the last lecture, that any transistor formed in a P-well is having a will give a less performance as compared to the transistor which is formed in an original substrate. But in this case, what is happening in NMOS, PMOS is formed, whereas PMOS is slower than NMOS. Basically, we know that the NMOS is faster than PMOS or PMOS is slower than NMOS, and here we are forming NMOS in a P substrate. So the performance will be degraded, but we know that the NMOS ka performance will reduce, but PMOS performance itself is slow. So both can be balanced. So that is the main thing in P-well process. Then we have seen the N-well process. No, before going to the N-well process, we have seen the latch-up problem, that the parasitic transistors are formed and with the help of that it is forming SCR, which is silicon controlled rectifier, and once that SCR will be on, then it will stop on degrading or destroying your whole IC. So this is nothing but this latcher problem should be avoided. In order to avoid the latcher problem, we can take a provision, like we can keep the beta of the transistor low so that the current will be less, and if the current will be less, this transistor will not be on only, or it will not reach to the very high level. Secondly, we can keep the R well and R sub resistances to be less. As these resistances will be less, the transistor will not become on. In order to keep the resistance on, the provision is nothing but we can use a epitaxial layer, which is a low resistance material. After that, we have seen the N-well process. In N-well process, the N-well is created in a P substrate. So the P substrate is a main substrate, and in P substrate the NMOS will be formed, whereas in N-well the PMOS will be formed. And now here if you see the performance, now how it will be formed, then after creating this well, then the gate will be aligned, and after formation of the polysilicon gate, then we are going for two diffusions. So here first of all P diffusion with the help of this mask, and then we are going for N diffusion with the help of this mask. Then we are going for the metallization in order to do the connection. Now the main drawback in N-well process is nothing but the performance of both the transistors will differ a lot, because here we are forming NMOS in a P substrate, which is a main substrate, and NMOS speed is faster. The performance is very good, whereas PMOS we are forming in N-well. PMOS itself is slow and we are forming in a well, hence the performance will be further degraded. So the performance of PMOS and NMOS cannot be seen. So that is a drawback of an N-well structure, N-well process. So this is a flow chart of what we have seen in N-well process. First of all, we are going to form a well. After that, the defined NMOS and PMOS active areas is nothing but what? Once the N-well is formed, that will automatically define what is your PMOS and NMOS area. After that we are going for field and the gate oxidation process. After that we are going to form a polysilicon gate. Then we are going for P-diffusion, then N-diffusion, then contact cuts. Contact cuts are nothing but we are making the windows for making a connection. And after that we are going to deposit and pattern the metallization. So and we are forming the contact. So and then we are giving the glass with the cuts for the bonding pads. So these are the nothing but a process for fabrication. Now we'll see the another method is nothing but twin tap process. Twin tap process is nothing but what, instead of having N well or P well, what we are doing, we are forming the transistors both in a well. That is nothing but, here first of all N substrate is taken, on which the epi layer will be, epitaxial layer is a low resistance material. Low resistance layer will be deposited, and then here we are forming the N well, and then we are forming in a P well, and in a P well we are forming NMOS, and in a N well we are forming a PMOS. So if you see, we can the performance will be depend. See, the performance is nothing but what, as we are forming both the transistors in a well, so the performance of the both the transistors will be affected, but that can be optimized. And another thing, the main benefit of this method is nothing but we are using this epitaxial layer. So with the help of this epitaxial layer, the chances of latch up will be reduced, because these are nothing but low resistance material, and that will reduce the resistance of the well and the substrate, and hence the chances of latch up will be less. Definitely, the twin tap process. We are going for some extra steps, but that depends on application. It depends on application ki whether we can pay much to this fabrication process, and we are getting like a benefit of like uh, benefit of avoiding latch up condition and this. So and the separate optimization we can get in winter process. So the only drawback is nothing but some extra steps are required in formation of this chip of this type. So I hope it is clear. So if you have any doubt you can ask. Thank you so much. In the next we will see the layout. Thank you.